In this question, we're asked to solve the equation x cubed plus 2x squared equals 5, given that it has a solution between x equals 1 and x equals 2. And we have to use a trial and improvement method. This is always worth 4 marks in the GCSE exam. And to get those marks, we need to show all of our workings. The first part of the workings will be to draw this table with column for x, a column for the left-hand side of the equation, which is x cubed plus 2x squared, and then a column for comments. All these comments are going to be whether or not our values are too large or too small, so it's nothing complicated. We begin by substituting in x equals 1, because we're told that the solution lies between x equals 1 and x equals 2. We substitute in our value of x equals 1 into the middle column. This will give you a value of 3, 1 cubed plus 2 times 1 squared. And if we do this, we get 3, but the equation should equal 5, so this is too small. So that's our comment. We now substitute in x is equal to 2, which will give you 2 cubed plus 2 multiplied by 2 squared, which you could substitute into a calculator. 2 cubed plus 2 multiplied by brackets 2 squared, and that will give you 16. Now that's too big because we want the right hand side to be 5. So the solution x equals 1 is too small and x equals 2 is too big. So that means the solution is somewhere between them, as the question says. So why don't we try x equals 1.5? We can then substitute in x equals 1.5, which should give us 7.875, and you can test that on your calculator. And that is too big. So logically, we're going to try something smaller than that. So why don't we try x equals 1.4? When we try x equals 1.4, we get 6.664, which is still too big. So why don't we try x equals 1.3? If we do that, we get 5.577, which is still too big. So now we are going to try x equals 1.2. And if we do that, we get 4.608, which is too small. Now that we've gone to 1 decimal place, and we can see that we're going from too big to too small, we know the real solution is somewhere between 1.3 and 1.2, but we only want our answer to 1 decimal place. So either our answer is x equals 1.3 or x equals 1.2. And to decide, we need to go halfway between 1.3 and 1.2, which is x equals 1.25, and then substitute this into the equation. We do that and we get 5.078125, which is ever so slightly too big. I'm now going to draw a number line with 1.2 on one end. I'm now going to draw a number line with 1.2 on one end and 1.3 on the other. Halfway between them, we obviously have 1.25. And underneath 1.25, I'm going to write that it's too big. Now, looking at the picture, if 1.25 is too big, then 1.3 is much too big. So that means the solution that we're going to use, even though we said it was too small, is x equals 1.2. And that is our value to 1 decimal place. So we say x equals 1.2 to 1 decimal place. Here's another example. A solution to the equation 2x cubed minus 3x minus 17 equals 0 lies between 2 and 3. Find the solution to 1 decimal place by trial and improvement. It's exactly the same method. We know the solution lies between x equals 2 and x equals 3. So I'm going to substitute in x equals 2. And if I do this, I get that we have minus 7. But we want to get 0. 0 is the right-hand side of the equation. So that's too small. If I substitute in x equals 3, I get 28, which is too big. So we know that the solution lies between 2 and 3, as we said in the question. So we're going to try x equals 2.5, which is halfway between 2 and 3. If we substitute that into our calculator, we end up with 6.75, which is too big because we want 0. So logically, we're going to go smaller and try x equals 2.4, which gives us 3.448, which is still too big. So logically, we should try x equals 2.3. Doing this gives us 0.434, which is just about too big, bigger than 0. So we're going to try x equals 2.2. Now, when we do this, we end up with minus 2.304, which is too small because it's below 0. So we know the answer is between 2.2 and 2.3. So we now have values to one decimal place. So we're going to go halfway between them to get 2.25, which gives us minus 0.98675, which is too small. And once again, I'm going to draw my number line with 2.2 on one end and 2.3 on the other, with 2.25 halfway between. Now, underneath 2.25, I need to write too small because when we put that into the equation, our result was too small. It was minus 0.98675. So if that is too small, then 2.2 is much too small. So the solution that we're going to choose to one decimal place is 2.3. So my answer is that x equals 2.3, and be careful, it is to one decimal place, and that's how I'd have to finish it. Here's a question for you to try. Please pause the video now and have a go at it, and when you're ready to go through the answer, press play. This is how we would do the answer. We would begin by drawing our table. With x, and this time the equation is x cubed minus 13x equals 107, and then our comment. So we know the solution lies between x equals 5 and x equals 6, so we'll begin by trying x equals 5. And if I substitute that in, I have 5 cubed, take away 13 times 5, and let's work that out. That gives me 60, which is less than 107, so that's too small. So let's try x equals 6, and you do have to show this for the full marks. So we have 6 cubed, take away 13 times 6, which gives me 138, which is too big. So we know the solution is between 5 and 6, so why don't we try x equals 5.5, which is halfway between them. So we end up now with 5.5 cubed, take away 13 times 5.5, and let's try that. Which gives you 94.875. Now that is too small because it's less than 107. So why don't we try something bigger than 5.5, 5.6. So we have 5.6 cubed, take away 13 times 5.6, and let's see what that equals. That's 102.816, which is still too small. So logically, we would try 5.7. So if we try x equals 5.7, if we substitute that in, we get 111.093. So I'm just going to put the workings in. 5.7 cubed, take away 13 times 5.7, 111.093. Now that is greater than 107, so that is actually too big. So we know that the solution is somewhere between 5.6 and 5.7, but we only want the solution to one decimal place, which we've already got. So either the answer is 5.6 or it's 5.7. And to check, I just substitute in what is halfway, 5.65. So we have 5.65 cubed, take away 13 times 5.65. Let's see what that is. So using the left arrows on my calculator, 5.65, take away 13 times 5.65, we get 106.912125. Which is too small because it's ever so slightly underneath 107. We now think about a number line with 5.6 on one end, 5.7 on the other, and obviously 5.65 halfway between them. 5.65 we've established was too small, which means that 5.6 is going to be much too small. So to one decimal place, our solution is x equals 5.7.